share the link at the end as well. And it's a very simple Django project with a simple to-do app. If you don't know Django, don't worry, you don't really have to know Django to follow this presentation. I use Django for the simple reason that Django app by default is a bit more complex than a bare-bone one-file Flask or Fast API application. So out of the box, we'll have some migrations to apply, and in general, we'll have more files lying around. This example project has a simple to-do app that interacts with a database. It has a bunch of packages in the requirements file, and actually only some of them are needed. I added a bunch of others just to slow down the build process. And it also has some tests that, again, are slow on purpose, so they either will sleep or perform some needlessly large mathematical operations just to slow down the pipelines. So we have something to improve. The build process uses Docker and Docker Compose. So Docker Compose will set up two services. We will have a Postgres database and a web container. And the web image is built from a pretty standard Docker file. So we specify Python 3.10. Yeah, we start with Python 3.10. We install some dependencies. We copy the code, and then we just start the server. So very, very simple setup. And this initial job has a pipeline that takes around 6 minutes to finish. It runs 3 jobs. So first, it builds the Docker image. Then we have a, that's the wrong button. Then we have a test job that will run migrations, and then it will run tests. Except that this job is actually badly designed, because the first time we run Docker Compose run command, we will actually build the Docker image from scratch again, even though we actually build it in the build stage. So this is something that I will improve a bit later. And finally, we have a deploy stage that just prints a message to the screen, and we can see that it still takes 54 seconds. So 54 seconds is the time it takes to set up a container for our job. So keep this number in mind. And of course, this example project is simple for demonstration purpose. It's absolutely not production grade. So maybe try not to clone it and use it in production. So I mentioned that my project is using Docker. Docker, or containers in general, are now a common tool in the DevOps world. They are also very well supported in most of the CI providers. So if you're planning to deploy your application to some cloud provider, using Docker inside of your CI is a good choice. And even if you do deployment without Docker, it's rather easy to wrap your application in simple containers. So if you do use Docker, the first step to improve your CI setup is to actually take a look at your Docker file and make sure it doesn't contain any of its problems. So make sure you use the layer caching properly during the build step. Make sure you use tags so you know which exact image you are using in your builds. Speaking of images, which one of those two you think is better? So we have Slimbuster, that is Debian-based image, or we have Alpine, which is a pretty bare-bone and tiny Linux image. So who here thinks Alpine is better base image? We have a couple of hands. Who here thinks Slimbuster is better? We have more hands, and I think the rest has a preference for some other image. Windows. The answer is it depends. So using Alpine usually means that you have to install a bunch of additional Linux libraries yourself. This will make your Docker file a bit more complex, and the build time might be a bit longer, but the final image will be smaller. So it will be much faster to download it or push it to the repository between your jobs. On the other hand, Slimbuster is twice the size of Alpine, which is still not that bad. If we were using Buster instead of Slimbuster, that's 15 times the size of Alpine. So it will take a bit longer to download, but the chances are that it will come with all the dependencies pre-installed, so we don't have to install anything. We can just run pip install and we are ready to go. So the build process will be simpler and a bit faster. In the end, your choice should depend on whether your pipelines spend more time building Docker images or pushing and pulling those images around. But Slimbuster is a good choice, at least in my opinion. One way we can speed up our build process is to not build the Docker image in each of our jobs, but to actually build it once and push it to the image repository so we can pull it in the consecutive jobs. So here we can see that even though we are building the Docker image in the build step, when we run the Docker compose run in the test step, it will rebuild the Docker image from scratch because jobs are independent. So the test job by default doesn't know that the build job already built that image. So we can fix that by pushing our image to the container registry at the end of the build job and then pulling it at the beginning of the test job. And yeah, we can see that by the way, I have like different branches in my Git repository corresponding to different parts of my presentation. So if we go here, we can see that now the build job is slower, but the test job is faster. So in my example project, the differences are tiny. A few second differences can come from the fact that maybe it took a bit longer to spin up the job container. And actually, if we check the test job in the logs, we can see that pulling the Docker from the registry and rebuilding it from scratch, in this case, takes almost the same amount of time. But your mileage may vary. Like if your build process takes long and you have many jobs, then it makes sense to pull the image from the repo. But if your build process is simple and fast, then maybe it makes more sense to just rebuild the Docker image from scratch. So you need to test different scenarios and see which one is faster. Another thing that you can do if you end up building massive Docker images is to use the multi-stage build. Multi-stage build means that you use a separate image for the build process. So you copy a bunch of files, you install plenty of Linux dependencies, then you run the build that can create temporary files and cache files and so on. And that image can grow in size, but you don't really care because in the end, you will just take the results of your build process and move it to a new image without all this cache, without all these additional dependencies and so on. And this multi-stage build works especially nice in languages where the build step will require you to install additional dependencies, but the final result will be, let's say, just one binary file, like it happens in Rust. In the Python world, this doesn't matter that much. In our example, we don't even install any additional Linux dependencies, but if we were using, for example, Alpine image, and we install a lot of additional Linux dependencies, then using this multi-stage build could give us some benefits, but with my current setup for the example project, it doesn't really make sense. Okay, let's leave Docker for now, and let's talk about CI pipelines. How can we make them run faster? So as your pipeline starts to grow bigger and your stages starts to include more and more jobs, you will realize that maybe some jobs unnecessarily wait for their turn because they are assigned to some later stages. By the way, who has a pipeline like that here? Actually, it's GitLab. That's the pipeline of GitLab itself. So they have quite a lot of jobs running. So you might want to look at the structure of your CI configuration and move things around. And for example, instead of running your jobs in sequential steps like here, you can run some jobs in one stage in parallel. So this pipeline will ultimately finish faster, except that what if one of the jobs in the stages fails? Now you're wasting computing resources running other jobs in this stage, even though you no longer care about the results of static analysis or preparing the release because you will have to go and fix the tests anyway. There is actually an open issue about canceling pending jobs if one of them fails, but it's open since 2018, so don't get your hopes too high that it's going to be resolved anytime soon. So there are always some design decisions involved in how you structure your pipeline, but in general I would say that the time you waste waiting for some pipeline to finish is much more precious than the cost of the build minutes, so parallelizing things is a good idea. And there are two ways how you can move things around between stages. So one way is called directed acyclic graph, or DAG, and you might this concept from other tools. So with DAG, you can configure one job to start after another job finishes, regardless of what stage those jobs are in. So for example, let's say you're testing your Python package under different Python versions, and for some reason you don't want to use a tool like Tox or Nox that can create multiple virtual environments with different Python versions. And instead you decide to build different Python Docker images with Python 3.8, 3.9, and so on, and then run tests and finally prepare the release. So here we have a build stage that will build all those different Docker images, then we have test stage, and we have the release stage. In the ideal world, all the builds will run in parallel and finish in more or less the same amount of time. In the real world, they won't. Some builds will take longer to finish, and if you're using a custom GitLab runner and you have a limit on how many jobs can run in parallel, then maybe some jobs will actually have to wait for their turn before they can start running. And in this case, there is really no point in having all your tests wait for your build to finish. I mean, if the Python 3.8 image is ready, then why does the test for Python 3.8 have to wait for Python 3.10 to start running? So that's where we can use the directed acyclic graph functionality and connect some jobs with their dependencies, regardless of what stage they belong to. So here we can see that the corresponding test and the release job starts right away after the previous job has finished. And in terms of code, all we need to do is to add this needs parameter that specifies which job has to finish successfully before this job can start. So here we have test 3.8 needs build 3.8 and release needs the test. So directed acyclic graphs are cool, but if you have a lot of jobs and you start connecting them throughout your whole configuration, it might be hard to follow what's going on. So instead of doing that, you can group some jobs together and create mini pipelines that can be triggered from your main pipeline. For example, let's say you're working on a project that uses a separate stack for backend and for frontend. That could be, let's say, Django REST framework on the backend with the React on the frontend. So then your backend code lives in the backend folder, your frontend lives in the frontend folder, and your backend tests probably don't depend on having the frontend up and running. And also, what's the point in running all the backend tests if you only change something in the frontend folder? So in this case, you can create one child pipeline for the backend part of your code and one child pipeline for the frontend. And in terms of code, this is how you can implement it. So we have two jobs, frontend and backend. And each of them contains a key called trigger, where we define where is the configuration for this child pipeline. And then we also specify a strategy. So here we say that we have a strategy depend. And that means that our parent pipeline should depend on the status of a child pipeline. So if the child pipeline fails, the parent pipeline should also fail. If we don't specify this strategy and the child pipeline fails, the parent pipeline will continue running. And also under the rules, we say that we only want to trigger this pipeline when something in the front-end folder changes, and the same for the backend pipeline. What else can we parallelize? Well, we can parallelize tests. And most of you who used PyTest before probably know about the PyTest XDist plugin. It will distribute your test across multiple CPUs, and that can get you some really good speed improvements if you're running PyTest on a machine with multiple CPUs. And if you don't, you can run your test across multiple runners. This is especially useful if you want to dynamically spawn new runners instead of paying for one large expensive multi-CPU server running all the time. So to do that, you need to install the PyTest test groups plugin, as we have here. And then you need to specify in the parallel option how many jobs you want to run in parallel. And you also need to pass two parameters. So we need to pass the test group count that defines how many groups we have in total. And we also specify the test group that specifies the index of the current group. So are we in a group 1, 2, 3, 4, or 5 out of 5 in total? And this setup is actually nicely supported by GitLab. So you have environment variables that you can just plug here. So this code that we see here, this is all you need to run our test in 5 parallel runners. And that's how it looks when we enable this feature. So if you check the parallel PyTest in groups branch, you can see that it takes 5 instead of 6 minutes to run the pipeline, but it also cost us more than twice in terms of computing credits as before. So that's because instead of having 3 containers as we had before, we are now starting 7 containers. 5 of them are needed for the test job. And as we saw at the beginning, just starting a job takes around 1 minute. So just starting those 5 containers will cost us 5 computing credits at the beginning. Other things that you should pay attention to is to make sure that your jobs are interruptible. So that is, if you have a pipeline running, but you push some new code to that branch, you want to restart this pipeline instead of running it until the end. And there are actually 2 steps here, which is something that not everyone is aware of. So first, make sure that in the settings of GitLab, you select this auto cancel redundant pipeline. So that will restart the pipeline if there is some new code pushed to the branch. This option is enabled by default, so you might take this behavior for granted and not really think much about it. But with this setting alone, your pipelines can only be stopped after the currently running job is finished. So they cannot stop in the middle of the job, which kind of sucks if you have jobs that run for a long time, because now you're wasting time and computing resources. So you can mark your jobs with interruptible true, and that means that they can stop in the middle of the run. So this is useful, for example, for your build or test jobs, because there you want to restart your job as soon as there is some new code. But for example, you probably don't want to use this option for your deploy jobs, because you don't want to end up with like partially deployed code on your server. It's better to finish the current deployment and just start a new one. Another thing is to stop tasks in your jobs when it doesn't make sense to continue running them anymore. For example, if your full test suite takes half an hour to finish, but the first test already failed, what's the point in waiting for all the other tests to finish? Because you will have to rerun those tests locally anyway, so you can, again, save some time and just fail the pipeline as soon as the first test fails with the PyTest -X option. You know how else we can make our CI faster? By not running things in the CI. So one of the biggest revelations for me was that you don't have to run every possible check in your CI on every possible pipeline. If you have a bunch of slow integration tests, then you can just run some of them on the main branches. For example, in my current project, we have integration tests that takes quite a bit of time because they are checking that all the apps that we have in our project, they can work nicely together. But that integration test takes around 45 minutes last time I checked. So we marked all of them as slow. And we moved those jobs to a separate interruptible pipeline that is only running on the staging and master branches. And that works fine. I mean, sure, we don't detect all the bugs right away, but at least we can merge requests fast. And we eventually get the feedback from the whole test run. And you can also run some particularly slow jobs manually or during the night. And I don't know how much time I have left, so I don't know if I should go very quickly or just quickly. 10 minutes. Okay, I'm just gonna go quickly, not very quickly. So some other random ideas to try. You probably know that you can cache things. For example, you can cache the pip cache between pipelines, and that should give you a bit of a speed up. But you can also specify the cache policy. So by default, each job that uses cache will download things from the cache at the beginning of the job, run the steps, and then push things to the cache at the end of the job. But maybe for some reason you don't want to do that because let's say your job is doing something destructive to the cache. So in this case, you can use the policy keyword to disable either pulling the cache at the beginning or pushing the cache at the end. Speaking of caching, you can select the fast zip compression method, and this will allow you to specify the compression level for your cache. And here you can select, for example, the fastest method that will run the fastest, but also the resulting cache object will be bigger. So it will take probably longer to upload it. So again, for this method, You have to play with which option will be the fastest for you, but it also plays nicely with the previous tip about the caching policies, because let's say you have a policy where you pull your cache in many jobs, but you push it only once or only in a few jobs. So in this case, it makes sense to actually select the slowest compression method, which will take longer to create a cache, but it will also result in a smaller zip object, and it will be much faster to download this zip multiple times. If Docker is slow to build your images, consider using one of the other builders. There is Builda, there is Kaniko, and they run with very similar commands as Docker, and they might be faster. They also have different features. And you can also use your own runners, and this is a very vast topic that could take a separate talk to dive into details. But using your own runner can, first of all, lower your cost, but also give you more flexibility. For example, we are using runners because we have some proprietary code that we cannot push to GitLab, so we're running all the tests on our own servers and just pushing the results back to GitLab. And yeah, just for a quick check, I started the runner on my computer, and I actually got some interesting results. So we can see that, here that the build job is faster, the deploy job is also much faster, which means that starting the runner on my computer is twice as fast as starting it on the shared VM. But running tests now takes around 10 minutes, which was super weird, especially that it was for those tests that were doing a lot of mathematical operations. So I would expect that my MacBook Pro with 16 gigs of RAM and 16 CPUs should be more powerful than a small VM in a cloud that the shared runners are using, but apparently Apple scammed me. But jokes aside, this drives the point home that CI is a complex beast, especially if you don't do DevOps on a daily basis, which probably applies to most of us here because this is a Python conference. So using a custom runner adds additional layer of complexity on top of the existing CI. Okay, so let's wrap it up here. Here are some key takeaways I want you to remember. Learn concepts, not tools. Even though I was focusing on GitLab CI here, all the concepts are universal. So I'm sure that whatever CI system you are using, there is a way to run some jobs in parallel and some jobs sequentially. So once you know that something can be done, it's just a matter of figuring out what's the configuration to make it happen. There are no silver bullets in terms of a perfect CI setup. Should you use an Alpine image and install all the dependencies, or should you use Debian and deal with the fact that the image will be bigger? Should you pull your images in each of your jobs, or should you build your images in each of your jobs? I don't know. That depends on your project. Not every check has to run in every pipeline. Some slow jobs can run manually or on the main branches. If there is newer code available, interrupt and stop the old jobs. Try to make your merge request pipelines fast and the main branch pipelines thorough. And also, if you think that you set up your CI at the beginning of your project and that's the last time you touch it, think again. Not updating your CI setup is just like any other technical debt. It will make your code reviews slower. It will delay important feedback for your developers, and it will make your developers more and more annoyed. So give yourself a favor and check from time to time what can be improved here. But overall, a well-designed CI can be a great tool in your daily work. Thank you very much for listening.
Thank you, Sebastian. So we have a few questions. Is there any easy way to get test coverage when jobs are run in parallel in multiple runnels?
That is a very good question. And honestly, I don't know, because in the previous talk, I was using the test coverage, and here I use the multiple runners, but I didn't check it. I remember reading about it, but I honestly don't remember what's the answer, so I'm not gonna bullshit myself out of it.
Okay. What's the tool you're using for highlighting stuff on the screen?
Keynote, with like a black rectangle with some opacity.
Can you repeat the difference between PyTest XDist and test groups?
Yeah, so the PyTest XDist is basically a tool that is distributing tests into different Processes or threads, I always mix them. But if you have a computer with multiple CPUs, then you can distribute tests into different processes. And if you're using PyTest group, it will actually spin separate containers for running your job. So, well, technically speaking, it will not be like one computer, but like separate computers, well, VMs.
Okay. How do I trigger pipelines in other repositories, like to check if changes in API doesn't break apps that are using this API?
So I think actually GitLab has a paid feature where you can have pipelines in Git submodules or even separate projects triggering pipelines from other projects. I don't know if it's within the same organization or actually different ones, but I only know that this is a paid feature. I don't know if there are like some open source alternatives to fix that.
Okay. Regarding that question about highlighting, is it some Mac function that
Highlight this.
this dot like?
Yeah, it's this guy. So it's Logitech remote controller that can do things like that. That's basically a mouse with some additional screen effects.
Okay. Thank you. Thank you, Sebastian. That's all.
Yeah.